Hello, we're going to be continuing on here. Before we were talking about the extreme values. Extreme! So we're going to continue on looking at that. We're going to add in another little step as we move along about figuring out when things are increasing and when things are decreasing. So a lot of what we're doing here will be similar, but just a little bit more on there, building on that. So I'm going to look at an example here to start off with. And let's say for our example, we have y equals x cubed minus 3 halves x squared minus 6x plus 4. And that's our function we're looking at. And to start with, much like we are doing before, we're going to want to find those extreme values. So what did we do last time? Hopefully remember, at any extreme values, maximums or minimums, the slope is 0. So we took a derivative and set it equal to 0 and solved that. So why don't you pause and work on doing that. Set this derivative after you've taken it equal to 0 and see if you can solve that. Hopefully you should be able to. All right, so hopefully you've taken a moment and worked that out on your own. If you're not, then you're really not doing like a very good job as being a student, let's be honest. When we take our derivative, we should get 3x squared minus 3x minus 6. We're going to set that equal to 0. And this is a quadratic equation, so you can factor it or do the quadratic formula. If we want to factor it, if we look at all of these terms, 3 and minus 6, they've all got 3, so I'd want to factor 3 out, and then I'm looking at that. That's a really easy one to factor now. Looking for factors of -2 that add up to -1. So that'd be a -2 and a +1. And if I set each factor equal to 0, I'd have x minus 2 equals 0. So x is 2 and x plus 1 equals 0, and x is -1. If you set 3 equal to 0, that's just a no solution. That doesn't tell you anything about what x is equal to. So we got those values. Now, I'm going to take this x equals 2 and x equals -1, and as we work on this next part with the increasing and decreasing, a really helpful way and useful way to work it out is to put it on a number line. Like you're going back into elementary school a little bit. So I got -1 and 2. And I'm going to be looking at these sections that are in my number line. I got a section over here, I got a section in the middle, and I got a section on the right. And what I'm looking for is it increasing or decreasing? And a way to know that is if we look at that slope. If the slope is positive, then it's increasing. If our slope is negative, that would be decreasing. Then what tells us about our slope that we've been dealing with? That's right, our derivative. So I'm going to throw that up here in the corner of my screen. And I'm going to look at what is the derivative for any value that's in these sections, like anything less than -1. I could pick like -2, and I'll figure out what's the derivative at -2. Anything in between -1 and 2, probably the easiest one would be 0. So I'm going to look at what's the derivative at 0. And then over here, any number greater than 2, let's say 3, just the next number, probably going to be the easiest. So you're going to plug in -2 here and figure out what it is. Plug in 0 here, plug in 3. So that'd be another time to pause quick and work that out on your own. A little bit of basic arithmetic practice and see what you get for that derivative at -2, 0, and 3. Hopefully you've got your numbers. I'm going to throw them up here on the screen real quick and not go over it step by step. But I got 12, -6, and 12. What I'm most interested in is not necessarily that it's 12 or -6 or 12, but whether or not it's a positive or a negative value. So in the left section, I got a positive, middle section is negative, and the right section is positive. And that'll be pretty common that when you go from one section to the next, that it would be changing, alternating. Not always, and we talked a little bit about that in the last part. You could have that critical point that's not a maximum or a minimum, but in this case it is. If I look at or think about what this graph would look like, it's increasing along here, so the graph would be going up, and then it would hit this -1 point, and then my slope gets negative, so it starts going down, hits 2, and then it starts going to increase again. So a rough sketch based on this would look something like that little curve there. So that tells me if I'm just looking at my number line in this section, my graph is increasing, and then I get to a maximum value right here, and then it's going to start decreasing again, and then I get to a minimum value here, and then it increases. So to close this off, if we're looking to find our extreme values and the sections where it's increasing and decreasing, now we just need to write this out more formally. If we are looking at, we found out our maximums at -1 and our minimums at 2, but we do want to find the actual point, x and y. So I'd look at that original function, and if I plug in -1 here, I got -1 cubed minus 3 halves times negative 1 squared, minus 6 times negative 1 plus 4. You do that correctly either on your calculator or using your great arithmetic skills. We should get our maximum is at negative 1 and 15 halves, or negative 1 and 7.5. Do the same thing to get our minimum. We know x is 2. If I plug 2 in here and work that out, I would get my minimum is 2 and negative 10 when I plug that into the original function to find that y coordinate. And then if I want to say, when is it increasing? So it's increasing in this section. If I'm looking at my number line, this would be when my values are less than negative 1. And it's also increasing when my values for x are greater than 2. So the way I'd write that, it's increasing when x is less than negative 1 and when x is greater than 2. So look at those sections on the number line here. And decreasing would be this middle section going from negative 1 to 2. So if I wanted to write that out mathematically, that'd be decreasing from negative 1 is less than x is less than 2 if I write that out with the inequalities. So that was an example there where we found our extreme values and our increasing and decreasing intervals. So we'll take a look at another one. It's just a little bit different, but similar ideas in the next video. And then it'll be your turn to practice a little bit.